Hello everyone. Today we are going to study about elements, compounds and mixture. So matter can be classified in a number of ways. Early Indian and Greek philosophers and scientists, they attempted to analyze and classify matter into 5 main elements, that is air, water, earth, fire and sky. So this was the early attempt that was being made by the Indian and the Greek philosophers and scientists of those time to classify matter into 5 main elements. So they classify the matter into air, water, earth, fire and sky. But later on in the modern science, there were 2 principal ways to classify matter. First on the basis of its physical state, and the second on the basis of its chemical constituents. So matter on the basis of its chemical constituents are of 2 different types, pure substance and mixture. So when you see below pure substances, you will find that further there are 2 different types of pure substances. One is the element like oxygen and hydrogen, another one is the compounds like those of the water and ammonia, and the other type of matter based on the chemical composition, it is of another type, that is mixtures, and the mixtures are of 2 different types, that is homogeneous. We can take an example of homogeneous mixture, salt and water, and the heterogeneous mixture, that is sand and water. So a pure substance is always homogeneous. Why did I say that? Because in a pure substance the composition is uniform throughout the given mixture, while in the case of the mixture the composition is not uniform throughout the given mixture every time. So it may be homogeneous or heterogeneous. So pure substances are the one which is made up of only one kind of molecules. So it has definite composition and properties. The characteristics of a pure substances are, it has fixed melting point and boiling point. It should have definite specific gravity, which means that in physics we have studied about what is specific gravity. So it's actually the comparison of the density of a given substance with that of the density of water. So it's actually how heavy a substance is as compared to water. So every pure substance will have a definite specific gravity, which means that comparable to the density of the water, it's going to be fixed. It should have uniform composition. It could be separated by chemical means only. Milk appears to be a pure substance, but it is a mixture of carbohydrates, fats, proteins, sugar, vitamins and minerals. We usually say that the milk is a pure substance, but milk is not a pure substance. It is a mixture of carbohydrate, fats, proteins, sugar, vitamins and minerals. So we have got 2 pure substances, one is the element, another one is the compounds. So elements or element is a pure substance that can neither be decomposed into nor formed from simple substances by ordinary physical method. There are about 118 known different elements, of which some of these are made by scientists while most of them occur naturally. So elements which occur naturally are called natural elements. For example, gold. So you will get gold from the nature. So for that reason it is called natural element. Elements that release harmful radiation. So there are some elements which release harmful radiation. Those type of elements are called radioactive elements. For example, uranium, plutonium, etc. So for the sake of convenience of the elements, elements have been divided into 4 classes: metals, non-metals, metalloids and inert gases. Metals and non-metals. Now, here are certain parameters that will help us to distinguish between metal and non-metal. So, metals have bright metallic luster, while non-metal do not have bright luster. Metals are good conductors of heat and electricity, while non-metals are poor conductor of heat and electricity, which means that it does not conduct heat and electricity. But metals usually are very good conductors of heat and electricity. Metals are highly ductile, which means that they can be drawn into wires, but non-metals cannot be drawn into wires, so they are non-ductile. Metals are malleable in nature, which means they can be beaten into sheets, while the non-metals are not malleable, they cannot be beaten into sheets. Metals have high melting point and boiling point, while non-metals have low melting point and boiling point. Metals are usually solid at room temperature, while non-metals can exist in all the three different states of matter, that is solid, liquid and gases. Metals are usually sonorous, which means that they produce a metallic sound on being struck, while non-metal are not sonorous. Some examples of the metals are copper, silver, gold, iron, aluminium and tin, while some examples of the non-metals are carbon, sulfur, phosphorus, iodine, oxygen and nitrogen. Now, there are certain exceptions which does not follow the common characteristics of the metal or the non-metal. Like as I said in the case of the metals, that metals are usually solid in room temperature, but there are certain metals like mercury and gallium which are liquid at room temperature. And there are even such solids which can be cut by the help of the knives. Those are soft solids like sodium and potassium. So, sodium and potassium are those elements, those metals which can be cut by the help of the knives. Usually metals are malleable or ductile, while zinc is neither malleable nor ductile, which means that it cannot be drawn into wires nor it can be converted into thin sheets. Tungsten is a very poor conductor of electricity, but metals are usually very good conductor of electricity. Now, we will go in some of the exceptions of the non-metals. Usually non-metals do not possess metallic sign or luster, neither it is a good conductor of heat and electricity, but we have got an exception, that is graphite. So, graphite is actually made up of carbon, and it's actually allotrope of carbon. So, it's different physical forms of carbon. These are the different physical forms of carbon, different physical forms. So, their chemical compositions are same. So, there are different allotropes of carbon like diamond, graphite, fullerene. So, one of these is this graphite. So, this graphite which is made up of carbon, because of its structure, crystalline structure, it possesses luster and it is a good conductor of heat and electricity. Iodine also possesses luster, while bromine is liquid at room temperature. So, both this graphite and iodine are solid at room temperature, while bromine is liquid at room temperature. So, okay. So, next thing is the metalloids. So, what are metalloids? So, metalloids are the elements whose properties are intermediate between metals and non-metals, whose properties are intermediate between metals and non-metals. So, they possess the property of both metals and non-metals, like arsenic whose symbol is As, antimony, Sb, germanium Ge, bismuth Bi. Now the Latin name of antimony is terbium. For that reason it's Sb. Now noble gases. So these gases are found in trace amount in the Earth's atmosphere. For that reason these are also called rare gases. So the noble gases are also called rare gas because they are found in very less amount. And now why they are called noble gases? Because they are non-reactive in nature. They do not react with any other element as they have fulfilled electronic configuration. So they are very stable. So for that reason these are called noble gases. So these are gaseous in nature. This is a completely a kind of element which are non-reactive, highly stable, and they are found in very less amount in the Earth's atmosphere. Since they are found in very less amount in the Earth's atmosphere, it is called rare gas, and because they are extremely stable, they do not react with other gases. For that reason they are also called inert gases. And there are only 6 noble gases still known to us, as helium, whose symbol is He, neon Ne, argon Ar, krypton Kr, xenon Xc, and radon Rn. Now we will move into the next pure substance, that is compound. So compound is obviously a homogeneous substance, so it is homogeneous in nature. As I said, every pure substance is homogeneous in nature. So it has fixed composition by weight. It is formed from its element by chemical reaction. So until unless two elements combine chemically by the help of a chemical reaction, a compound is never formed. The properties of a compound are different from those of constituent elements. A compound has a definite melting and boiling point. For example, you can see that if we consider water as an example, which is a compound, its melting point is always 0 degrees Celsius irrespective of from wherever you collect it, and its boiling point is always 100 degrees Celsius irrespective of from wherever the source of water is. Now here you can see the difference between the constituents of the water from which it has been formed. So in the case of the hydrogen, it's gaseous in nature at standard temperature and pressure. Oxygen is also gas, water, but water is usually liquid at normal temperature. When we talk about flammability, hydrogen is flammable, which means that it burns in the presence of the oxygen, but it does not support combustion, while oxygen supports combustion but does not burn. So it's not combustible but supports combustion. Water has none of these property, neither it supports combustion nor it is combustible in nature. So melting point of hydrogen, you can see it's minus 259.16 degrees Celsius. In the case of the oxygen, is minus 218.79 degrees Celsius. Now in the case of the water is 0 degrees Celsius. The boiling point of the hydrogen is minus 252.879 degrees Celsius. In the case of the oxygen is minus 182.962 degrees Celsius, while in the case of the water is 100 degrees Celsius. So you can see that the properties of the constituent of the elements which are present in the compound are completely different from that of the elements present in the compound, as in the case of the water. Now we will do an activity that will make the understanding of the compound much more clear. So activity 1. So method will take 7 gram of iron filling and 4 gram of sulfur powder. Mix the two and transfer it to a test tube. Heat the mixture strongly for some time. What do you observe? Black compound of ferrous sulfide is formed from the mixture. Equation is, so iron plus sulfur produces iron sulfide. So this happens. Now the property, now the element react with an element to form a compound. So iron is an element, sulfur is an element, iron sulfide is a compound. Now here the properties of iron sulfur and iron to sulfide is completely different. If we see the ferromagnetic property of the iron, it's ferromagnetic, so it's attracted by the magnet, while sulfur is not attracted by the magnet. Iron sulfide is also not attracted by the magnet. The melting point and boiling point of iron sulfide and iron sulfide is completely different from each other. If you see the color, iron is grey in color, sulfur is yellow in color, while iron sulfide is black in color. The solubility of iron in carbon disulfide is not seen. So, only sulfur is soluble in carbon disulfide, but iron sulfide is not soluble in carbon disulfide. So, let us see a video that will help us to understand it much more clearly.
Just as a warning, this reaction produces highly poisonous SO2 gas. This must only be carried out in a well-ventilated area or a fume hood. Also, the reaction between iron and sulfur is extremely exothermic and very high temperatures are reached. Ignited using a hot glass stirring rod, iron powder and sulfur powder react together extremely exothermically. For this experiment, only iron and sulfur powder is needed. The amount that you need will depend on how much you want to make. You can make any amount as long as you maintain the mass ratio of 7 grams of iron to 4 grams of sulfur powder. First, I added 35 grams of iron to 20 grams of sulfur. I then poured the powder between each beaker back and forth until the mixture became relatively homogeneous. When mixing two reactive powders, this is often the best method to use. Mechanical stirring, or even worse, grinding with a mortar and pestle, could lead to the spontaneous ignition of the mixture. You might notice that there are still quite a few clumps of sulfur in the final mixture. For our purposes, this is okay. However, if you wish to avoid this problem, simply use dry sulfur and fully powderize it before using it. Now that we are done mixing the powders, we are ready to react them. The best and most impressive way to set off the reaction is to simply heat up a glass rod and place it into the powder. The temperature of the glass stirring rod only has to be a little over 100 degrees, which is the melting point of sulfur. When the sulfur melts, its reaction with iron will begin. So the reaction that's going on here is actually quite simple. Simply put, the solid iron and the liquid sulfur combined form iron 2 sulfide in an extremely exothermic reaction. This reaction should only take place on something that can withstand the high heat. This means it should be carried out on something like concrete or a high melting point metal, not aluminum, because aluminum will melt at around 600 C. Also, absolutely no glass, porcelain, or organic polymer of any kind. This reaction is interesting, but the final product, iron 2 sulfide, is actually a useful product. The iron sulfide from this reaction can be collected and reacted with hydrochloric acid to produce hydrogen sulfide gas. It has a rotten egg smell and it is extremely poisonous. Its toxicity is comparable to that of hydrogen cyanide. However, despite its significant toxicity, hydrogen sulfide gas is used in a multitude of chemical processes. I'm providing this video to show you why you should not carry out the reaction on glass or porcelain. The reaction is extremely exothermic and it can easily crack and shatter glass. In the end, you are left with a very hard, dense material that is stuck to the end of the glass stirring rod. If you are interested in keeping the iron 2 sulfide, then you can wait till it cools, break it up, and put it into a container. Just as a warning, powdered iron 2 sulfide is pyrophoric, which means that you probably shouldn't powderize it as it might ignite on contact with air.
That was very interesting. Now, before we go into the next topic, let us know a little bit more about this particular iron sulfide. So, as we have studied, so we have taken two test tubes in which in one of the test tube iron and sulfur is present, while in another test tube iron sulfide is present. So that's a compound, and this is the mixture. So a chemical test to find out whether iron and sulfur is present in here or not, and in the other part iron sulfide is present. So how you are going to find it out? So what we are going to do is that we are going to add dilute hydrochloric acid. So when you add dilute hydrochloric acid to the mixture of iron and sulfur, you will see effervescence of hydrogen gas. So effervescence of hydrogen gas is been observed. Effervescence of hydrogen gas. Now that hydrogen gas burns in the presence of oxygen and a small spark with a pale blue flame. Why does that happen? Because iron reacts with HCl, dilute hydrochloric acid, to form ferrous chloride and hydrogen gas. While in the other case, when you add dilute hydrochloric acid, here you will find effervescence of another gas. So here you will get effervescence of hydrogen sulfide gas, which has got a rotten egg smell. Okay, so H2S has got rotten egg smell. Now why does that happen? Because iron sulfide reacts with HCl to form ferrous chloride and hydrogen sulfide Okay, so this hydrogen sulfide has got the rotten egg smell. So here you see that iron sulfide has got completely different property as compared to the element from which it has formed. Okay. Now we will go into the mixture. So mixture is formed when two or more substances are mixed together in any proportion such that they retain their individual properties and can be separated by physical means. Air is a mixture and its components are separated by fractional distillation of liquefied air. So here you can see that air is first been cleaned. So you get clean dust free air by centrifuging the air through a centrifugal machine. So first the dust is been removed from the air, then it is been compressed and cooled to produce liquid air, and then slowly it is allowed to warm out. So the first fraction that is been obtained is nitrogen, which because its boiling point is minus 196 degrees Celsius. Then when it is further allowed to warm, then the fraction 2 is obtained, that is argon, whose boiling point is minus 186 degrees Celsius. And finally leaving behind fraction 3, which contains oxygen, whose boiling point is minus 182 degrees Celsius. Now what are the characteristics of mixture? The constituents of a mixture may be present in any proportion. Only physical change takes place during the formation of a mixture. No energy change takes place during the formation of a mixture. The constituents of a mixture can be separated by physical means. So you can easily separate by physical means. So you will see that when we study the separation of the mixture in another slide presentation, in another one of our classes, you will understand the different techniques which are used to separate the constituents of the mixture. So the mixture does not have a fixed melting and boiling point. So the mixture does not have fixed melting point and boiling point. Why? Because here there is no formation of a single compound. The element or the substance or the compound mixture, they continue to possess their own identity or chemical properties. So for that reason they do not have any fixed melting and boiling point. So air is a mixture of gas. So all gases are mixed thoroughly, but they retain the individual properties. These gases can be separated from each other by physical processes. The constituent gases do not undergo any chemical change. The composition of different gases is not uniform. So these are the reason why air is a mixture of gases. So why do we call air as a mixture? Because of these 4 reasons. Now some examples of a mixture is: smoke is a mixture of carbon particles and air, gunpowder is a mixture of nitre, sulfur and charcoal, while brass is a mixture of copper and zinc. So the types of mixture, there are 2 different types of mixture. Homogeneous mixture, a mixture in which constituents are distributed uniformly. For example, salt in water and alloy. So usually a solution is a homogeneous mixture of solute, the solid which is dissolved or dissolved substances in a solution, and solvent which is a liquid substance that dissolve other substances. Alloys are the homogeneous mixture of one metal with another metal or of a metal with a non-metal, for example steel. So when the substances which are mixing with each other, they have got uniform composition. So if you consider a glass of water, a glass of salt solution, so it's common salt and water. So if it contains common salt and water, so when you taste water containing common salt from any corner, you will see that it's uniform throughout. The taste won't change too much. The reason behind, because it's an homogeneous mixture and it's same throughout. It is also true for the case of the alloys. So alloys are the solid mixture, solid homogeneous mixture of one metal with another metal. Usually a metal is mixed with a metal, but in some case metal is mixed with a non-metal, for example steel. So heterogeneous mixture, a mixture in which its constituents are not distributed uniformly, it is called heterogeneous mixture. For example, sand in water. For example, sand in water. Okay, so today we have studied till mixture, and the basic idea has been obtained from this slide. On the next class, we are going to study about the different types of solution. Okay, thank you. For latest update, please subscribe the channel and you will get notification at your YouTube whenever I add a new video. And if you have any doubts, please feel free to comment in the comment box. Okay, thank you for being in the class, for being a part of this video. That's all. Thank you. Have a nice day.